So this is the second part of the section 5.2 lesson video. And so in the first part, we learned how to do the electron configuration using the arrow form, or arrow electron configuration. In this video, I'm going to show you how to do the standard electron configuration. So when you write the electron configuration in standard form, the number of electrons in each sublevel is just written as a power. So instead of having to draw those blanks, like for example, say we have 2p and it looks like this, 1, 2, 3. Instead of drawing all the orbitals and the electrons as arrows, we just say, okay, well 2p has 3 electrons. So a lot of you like standard better because it's a little bit shorter and easier to do. However, on tests and quizzes, I always specify which form I want, and so if I ask for arrow, unfortunately, you got to give me arrow. So you fill the sublevels in the same order that followed the periodic table, but afterwards we rearrange the sublevels to be in number order. So that's kind of confusing in the beginning, but again, once you see a few examples, it'll be fine. So like if we're filling in, we're going to go 1s, 2s, 2p, 3s, 3p, 4s, 3d. That's the order that it is on the periodic table. But when you do it in standard configuration, it's common practice to then rearrange and keep 3s, 3p, 3d together. But don't fill them in this order. You still follow the periodic table, but then we'll rearrange it at the end. Now some people, they force you to rearrange, some people don't. You really just need to find out what your teacher prefers. In my class, I prefer you to rearrange because I want to make sure you know what you're doing. And when we start talking about ions, the rearranged way helps when we're doing ions. So just check with, if you're not in my class, with your teacher as to whether or not they're going to force you to rearrange. So instead of going this way, I went ahead and wrote these elements down. I'm going to go back to my periodic table. And so if you don't have your periodic table labeled from the first part of the video, make sure you label it this time. So remember, the yellow are my S's. So S starts with 1. So it's 1S, 2S, 3S, 4S, 5S, 6S, 7S. P starts with 2. So it's 2P, 3P, 4P, 5P, 6P, 7P if you have anything down here on your periodic table. D starts with 3. So 3D, 4D, 5D, 6D, and F starts with 4. So it's 4F, 5F, just like that. All right, if you're confused on where I have labeled this from, then watch the first lesson video for section 5.2, and I'll label this a little more slowly. All right, so I'm just going to continue what would be in your notes packets or what's on the PowerPoint. And so the first one is F. So remember, we just find it and circle it. So F has 9 electrons. All right, and so all we're doing is instead of drawing all the orbitals and filling in all the arrows, we're just doing powers. Okay, so I'm going to go really slow on the first couple, and then I'm going to speed it up a little bit. All right, so remember, same rules. Start at hydrogen. So where are we? We're at 1s. 1s has 1 orbital and can hold 2 electrons. 1 for hydrogen, 1 for helium. I need both of them, so I just put a little 2 up there. So it's just like this is the same as this. So I have 2 arrows, so I just write a 2 power. It's just a lot faster. Okay? So then I move on to lithium. Well, now we're at 2s, so I write 2s. 2s can hold 2 electrons. Lithium, beryllium. I need both of them, so I just put a little 2. All right, now I'm at boron, so I'm at 2p. Remember, 2p can hold 6, but I have to stop at the element I circled. 1, 2, 3, 4, 5. I only need 5, so I'll put a 5 there. That's it. You can't even mess up with Hund's rule on this one because I can't see what orbital you put it in. And so then you just check your answer. I need 9 electrons, so I have 2, 4, and then 4 plus 5 is 9. So to check your answer for this, you just add up your powers and make sure it's the same as your atomic number. So see, it's super easy. All right, now if you didn't understand arrow configuration very well, this is a little bit trickier. So make sure you know arrow before you start trying standard. All right, so let's move on to our second example, which is nickel, Ni. All right, so we need 28 electrons. So again, we start at hydrogen, so I'm at 1s. S can hold 2, 1 for hydrogen, 1 for helium. Now I'm at lithium, so where am I? I'm at 2s. It can hold 2, lithium, beryllium, so I do 2s2. Now I'm at boron, so I'm at 2p, and I need 1, 2, 3, 4, 5, 6. So I do 2p6. Then I come over here to sodium. Now I'm at 3s. 3s can hold 2, 1 for sodium, 1 for magnesium. So then I come over here to aluminum. Now I'm at 3p. I need all 6. 1, 2, 3, 4, 5, 6, because that gets me to argon. Then I come down here, I'm at potassium, so I'm at 4s. And it holds 2. Potassium, calcium. So I put 2. Now I'm at 3d. It can hold 10, but remember I stop at the element I circled. 1, 2, 3, 4, 5, 6, 7, 8. So I'll put 8. Now here's where the rearranging comes. And please don't rearrange for arrow configuration. Alright, so you see how the big numbers in front is a 1, 2, 2, 3, 3, 4, 3? All you do is you want to keep all the sublevels of one energy level together. So I want it to go 1, 2, 2, 3, 3, 3, 4. So all I'm going to do is take these last two and just switch them. So I'm going to do 3d8 and then 4s2. The reason this becomes important is when you start taking away electrons and adding electrons for ions, you have to use from the highest energy level. And so if you have 3D listed last, then you in your mind are probably going to think that's the highest energy level, even though 4s actually is. So that's one of the reasons why I make my students rearrange. All right, so that's where the rearranging comes. It won't happen until you get to 3D. Because all the way up through 4s, everything's already in order. Once you hit 3d is when you'll have to rearrange. Now, you have to be careful. Sometimes you may need to rearrange in more than one spot. Just check all your numbers and make sure they're good to go. All right, and I'll show you one where you have to rearrange in more than one spot. All right, so the last one we're going to look at together is gallium. GA number 31. And don't forget, you can add up your powers to check your answer. If you follow the periodic table, though, you shouldn't really need to check your answer. All right, so I'm going to go a little faster. So we start at hydrogen, so I'm at 1s. It holds 2, hydrogen, helium. Now I'm at lithium, 2s, holds 2, lithium, beryllium. Now I'm at boron, 2p. It can hold 6. That gets me all the way through neon. Now I'm at sodium, Na, 3s, can hold 2, sodium, magnesium. Now I'm at aluminum, 3p, it can hold 6. I need all 6 to get me through argon. Now I'm at potassium, which is 4s. It can hold 2 for potassium and calcium. Now I'm at Sc, I'm in 3d, and I need to get all 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get through Zn or zinc. And now I'm at 4p. It can hold 6, but I only need how many? 1. All right, and the 1 is not understood, so don't just end with 4p. You got to put the 1. All right. Some people, they think that you're supposed to stop right before the element. Remember, stop at the element you circled, so still count that one too. And so if you add up all your powers, you can check to see that there's 31. So there's 2, 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 6 is 18, 18 plus 2 is 20, 20 plus 10 is 30, and then plus 1 more is 31. Okay, so always, especially at the beginning when you're new, check your answers. Make sure your powers equal your atomic number, which since we're talking about atoms is also the number of electrons. All right, so for the next 3, I want you to try them. So just pause the video. You can try all 3 and then check your answers. You can do one at a time. It's up to you. All right, so I'm going to assume you've already tried it. So let's move on to our next one, which is calcium, Ca. All right, so you're going to start all the way up at hydrogen. Hydrogen is 1s. It can hold 2, hydrogen, helium. Now I'm at lithium, 2s, it can hold 2, lithium, beryllium. Now I'm at boron, 2p, it can hold 6 to get me through neon. Now I'm at sodium, which is 3s, it can hold 2, which is sodium, magnesium. Now I'm at aluminum, which is 3p, it can hold 6, which gets me through argon. Now I'm at potassium, which is 4s. It can hold 2, and I need 1, 2. So I end just like that. All right? And so you'll notice on this one, all our numbers are in perfect order. We have 1, 2, 2, 3, 3, 4. All right, just like that. Now on the previous one, I probably should have stopped and rearranged. rearranged. I didn't just because, again, some teachers don't force you to rearrange, but on the previous one for gallium, I probably should have rearranged, just since I make my students rearrange. But that's okay. All right, so let's hope you got that one right. Let's look at our next one. Our next one is, the hardest one. You can do this one, you can do any of them, and that is AG. All right, so we're gonna have to go really low, so I'm gonna write small, and then I'm gonna make sure to show you how to rearrange on this one. If you haven't tried this one already, just be careful because there's 2 spots that you need to rearrange. All right, so we're gonna start at hydrogen, which is 1s. I need 2, hydrogen, helium. We're now at lithium, 2s. I need 2, lithium, beryllium. Now we're at boron, 2p. I need all 6 to get me through neon. Now we're at sodium, 3s. I need 2, sodium, magnesium. Now we're at aluminum, 3p. I need all 6 to get me through argon. Now we're at potassium, which is K, 4s. I need 2 for potassium and calcium. Now we're at 3d. I need all 10 to get me through zinc. Now we're at 4p. I need all 6 to get me through krypton. Now we're at 5s, rubidium, which is Rb. I do need 2, it's Rb, Sr. All right, now we're here at 4d. We're at Y, and I need to count over 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let me show you that rearranging thing again. All right, so if you look, we have 1, 2, 2, 3, 3, 4, 3, 4, 5, 4. Okay, so in other words, what I need to do is I need to switch the 3d10 and the 4s2. All right, so now I have 1, 2, 2, 3, 3, 3, 4, 4, 5, 4. So now I need to switch these 2. But notice this is a 4d9. Don't accidentally change it to a 10. So it's 4d9, 5s2. All right, if you got that one right, you are also amazing because, like I said, that was a lot. There's 2 places to rearrange. You had to go pretty low on the periodic table, so hopefully you got that one right. If you didn't, though, there's still one more for you to try. And the last one on the PowerPoint is aluminum, Al. Now see, on this one, you won't make it to 3D, so you won't have to worry about rearranging. All right, so I'm going to assume you've already tried it. So we're going to start at hydrogen, which is 1s, 2, hydrogen and helium. Lithium is 2s, 2, lithium and beryllium. Boron is 2p, 6. That gets me all the way through neon. Sodium is 3s, 2, sodium and magnesium. And then aluminum, we're at 3p and we only need 1. And see, notice I don't need to rearrange. 1, 2, 2, 3, 3, and we're good to go. All right, so hopefully you're getting the standard. Again, most of you like standard more, but you just have to go with which one I ask you. Okay, so let's move on and talk about some exceptions to the rules, because there's always going to be exceptions. All right, so these are from the first lesson video for this section. All right, and so here's the ones that we just did. So notice for nickel, we rearranged and put that 3s before, the 3d before the 4s. For gallium here, I went ahead and rearranged for you. I moved that 3d10 before the 4s too. And then here's calcium, silver, and aluminum. These I just went ahead and rearranged them as I went. All right, if you take honors, I teach noble gas configuration, but I don't do that in regular anymore. All right, so let's look at some exceptions to the rules. So sublevels are the most stable if they're all the way full, but they're still pretty stable if they're half full. Think of it as kind of being balanced, like a p sublevel. Say we have 2p. If it's all the way full, then each orbital has 2 electrons. If it's half full, then each has 1. It's kind of like it's all stable, balanced. But once you take away this one, see how it's not balanced anymore? So sublevels, they're most stable if they're all the way full, but they're still really stable if they're exactly half full. So like a D sublevel is very stable with 10 or still really stable with 5. This causes electrons to jump to different sublevels in order to make an atom more stable. This jumping does not happen until the 3rd energy level, And there are only 2 exceptions that you need to memorize. So notice that means there's more than 2. There's way more than 2. The lower you go on the periodic table, the more exceptions there are. But you just need to learn the first 2. So don't try to make up your own exceptions once I teach you this. All right, so it says write the standard electron configuration for chromium. All right, so chromium is Cr on the periodic table. Okay, I'm not going to click back to my periodic table just because it's kind of far back in the PowerPoint. So hopefully you have yours to look at. And so Cr is element number 24. So it has 24 electrons. All right, so it says write the standard, so we're going to do the powers. So go all the way up to hydrogen. You're at 1s. It holds 2, hydrogen, helium. All right, next we're at lithium. It's 2s. It holds 2, lithium and beryllium. Then we're at boron, which is 2p. It holds 6. That gets me all the way through neon. Now we're at sodium, which is Na, 3s. It holds 2, sodium and magnesium. Now we're at aluminum, 3p. It holds 6. I'm going to put all 6 because that gets me through argon. Now we're at potassium, which is K. That's 4s. It holds 2, potassium, calcium. Now we're at Sc, which is in 3d. And so then I count across until I get to chromium. So I would do Sc, Ti, V, Cr, and that is 4. So one thing that I would need to do is I would want to rearrange because of course right now my 4s is before my 3d. But before we do that, let's talk about the exception. So see how all of these are stable? They're completely full. 3D is not stable. It's not completely full with 10. It's not even really stable with 5. So what happens is because 3D and 4s are getting so close together, you remember when I showed you how the levels get closer together as we get farther from the nucleus, 4s is like, hey, I'll give you 1 so you can be stable. So see how now 3D has 5, so it's half stable? Well, isn't S still stable? Because it's stable with 2 or it's stable with just 1. All right, so that's what happens is 1 electron from 4s goes to 3d. 3d is a much larger sublevel, so it's more important for it to be stable. But don't forget to make sure to rearrange your sublevels. So I would have 1, because I need to put my 3d before 4s, so I'd have 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. And you don't have to circle them. I'm just circling them to make sure you remember that's where the exception happened. 1 from 4s jumped to 3d, so that they would both be stable because now they're both half full. All right, this is one time you will do the exception with chromium. The other exception that I want you to know is copper, which is Cu. Remember, there are more exceptions than these 2, but these are the only 2 times that I wanted you to show me you know the exception. Okay, so again, since 3d is almost half full, 1 electron from 4s moves to 3d, and then of course we have 3d before 4s in our final answer. So it says write the standard electron configuration for copper. Something very similar happens. So copper is Cu. It has 29 electrons. So again, let's just write the normal standard. So I'm going to start with hydrogen, 1s2, hydrogen, helium. I'm at lithium, 2s2, lithium, beryllium. I'm at boron, 2p6, that gets me through neon. I'm at sodium, 3s2, sodium and magnesium. I'm at aluminum, 3p6, that gets me through argon. I'm at potassium, 4s2, that gets me potassium and calcium. Now I'm at Sc, scandium, which is 3d, and I count across to copper. So again, just count on your periodic table, it goes to 9. So again, D is almost full. So what do you think is going to happen? 1 from 4s is going to come in to make 3d stable. So the same thing happens in both exceptions. 1 from 4s helps 3d become more stable. But then don't forget, when you rewrite it, make sure you move 3d before 4s. So your final answer would look like this. Okay? So again, don't use your exception for any other elements but chromium and copper. Okay, I don't want you making up exceptions. Sometimes they get really weird where a lot of stuff starts jumping and it kind of doesn't make a lot of sense. So just focus on showing me the exceptions for copper and chromium only. Everything else, I prefer you just to follow Papa's principle. All right, so what are the three rules for writing the electron configuration of elements? Well, there's Aufbau's principle, Pauli exclusion principle, and Hund's rule. Number 2, explain why the actual electron configurations for some elements differ from those assigned using Aufbau's principle. Well, that's like chromium and copper. Sometimes electrons change sublevels to make them more stable. Okay, sometimes electrons jump to different sublevels to make them more stable. Number 3, arrange the following sublevels in order of increasing energy. Well, you know how it goes on the periodic table. We start with 1s, that's not a choice. Next is 2s, that's not a choice. Next is 2p, so there's a choice. Next is 3s, then 3p, then 4s, then 3d. Sorry about that. All right. So number 4, why does one electron in a potassium atom go into the 4th energy level instead of squeezing into the 3rd along with the 8 already there? Remember, electrons can't squeeze places. If a sublevel or energy level is already full, you have to move on to the next one. All right, so once the sublevel or an energy level is full, you have to move on to the next one. All right, so hopefully you think electron configuration is pretty easy because I super love it, so hopefully you're starting to like it a little bit.